let's go. Hello and welcome everyone. Welcome to episode 15 of Azure Community Live. This is actually the second show of the day. So this morning we broadcasted from Australia, where Lars had a nice session with our guest Oren on Azure Security. And today our second show of the day, this time from the Netherlands, with 2 Dutch guests as well. Last week was an announcement of Red Hat and Microsoft on doing Red Hat OpenShift on Azure. So we thought let's do a session about this topic to see what it's all about. And that's why we have invited 2 guests, Wian and Roy, one from Red Hat and the other one from Microsoft, to explain us this story. So it's an unusual time for us, the afternoon session. So we wanted to give that a try as well. We've seen different audiences in the evening, afternoon, lunch sessions. So we're just experimenting. So let us know in the chat if you have any comments on what times do you prefer. These are crazy times with everyone working at home. So might that other time slots work better for other people during these times as well. So just interact with us in the chat. I will have a look at the chat on what's going on. And with no further ado, I will pass the mic to Roy and Wian. Can you introduce yourselves and then go ahead with your talk on Red Hat OpenShift on Azure?
Sure, Wian, you go first.
Yeah, let me go first. Hi and welcome. My name is Wian Vos. I am a solution specialist at Red Hat, and therefore I'm supposed to be an expert on everything OpenShift. Now, with the launch of Azure Red Hat OpenShift, we are very pleased to tell you guys about it together with Microsoft. Roy, you want to introduce yourself?
Yeah, sure. So I'm Roy. I work for Microsoft. I work as a cloud native specialist, basically helping our customers, partners to be successful in the cloud native space. Obviously, OpenShift on Azure, Azure Red Hat OpenShift, the offerings that we have and that we are co-engineering together with Red Hat are extremely important for us from a strategic level, but also to help the customers in this whole cloud native space. So yeah, that's basically me and what I'm doing. I work a lot with Wian together, so that's why we're doing the session also together. It is a service from Red Hat and from Microsoft. We jointly engineered it, and I'm really excited to talk about it and show you a quick demo on how to deploy it, how does it look in Azure. And I know Wian got some awesome stuff as well up his sleeve to showcase to you guys this evening.
Yeah, I have some really cool features at the end. So stay tuned.
So,
okay, let's go.
Yeah, we will start off with just a couple of slides, and I know slides is probably not the thing that you guys are all wanting to see, but just to have the same playing level. We did the introduction, obviously, Microsoft and Red Hat, and the only thing I want to say about this is we are doing a lot together, and we have this strategic partnership across the world, where we are helping our customers in their digital transformation. We are doing that with RHEL on Azure. We're doing that with OpenShift on Azure, SQL Server on RHEL, obviously, and Red Hat Linux for SAP solution for Azure. It's quite an extensive and strategic partnership that we are doing. So if we're looking at OpenShift, that is what we're going to talk about today. Actually, what we are seeing is by customers who are adopting OpenShift as their core strategic application platform, we enable cloud native applications, we enable AI and machine learning type of scenarios, analytics, Internet of Things, and culture of innovation. And this is actually pretty cool. We can now talk to our customers around innovation and really help them on a technology level and on the business level, and combining those 2 together, right? Wian, can you maybe explain a little bit about the next slide and what you mean and what we mean with Kubernetes done right is hard?
Yeah, so if you look at Kubernetes and the way it's manifesting, Kubernetes is a has become a really big a piece of software. It's actually, in lines of code, comparable to a medium-sized operating system. So yeah, keeping track of all the moving parts and all the updates that are they're constantly hitting the market. It's a lot to manage and to administer. So we, as Red Hat, in our mission to help customers adopt open source safely, have created a distribution of Kubernetes and basically it's the same thing as we did with RHEL. So we took the open source software, we added stuff to make it usable, and we added our standard support on top of that. So yeah, and we're doing that to make using Kubernetes in the form of OpenShift easier for our customers, so that they can actually focus their time on what they need to be focusing on, creating business value.
Amazing, thank you. Yeah, so basically what we're seeing is if managing, operating, installing, configuring Kubernetes is complex. And I think OpenShift takes a lot of that away. You basically get Kubernetes on steroids. You can immediately jump into the business value and the development of the application and focus on that. Quite amazing, right? So what we also see with the offering that we right now are having is you need to think, when jumping into the cloud native space, you need to think about a lot of things. You need to think about your application delivery, CI/CD, security, day two, how do you do all those type of things, networking, platforming, SLAs, and so on, right? And this is actually something that OpenShift solves for you, and has a lot of building capabilities that help you with the day two operations and that help you with the security of your platform, of your applications. So that's pretty cool. So Azure Red Hat OpenShift, when we talk about a managed service. The customer is focusing on delivering the application and focusing on the OpenShift part. We, together with Red Hat, we manage the environment for you. And if you look at the screen that I've put up right now, we will give you support. The customer will have a single contact of support for their platform, which is Azure, but also for the OpenShift components and for the OpenShift platform. So if a customer wants to have a fully supported end-to-end environment, this is actually pretty cool. Also, what we are seeing with Azure Red Hat OpenShift, you get to that application development much faster because we will take care of some of the security and patching and making sure that the worker nodes are spread over availability zone and those type of things, right? That you want to have because you want to have a enterprise level container orchestration platform, right? This is actually pretty cool. This was announced last week during Red Hat Virtual Summit. So we released ARO version 3.11 based on OpenShift 3.11, obviously a year ago. We worked closely together, and last week we announced the general availability of Azure Red Hat OpenShift running on OpenShift 4. So right now the version that we're supporting for OpenShift is version 4.3. Which is a game changer. If you compare OpenShift 3 with OpenShift 4 on a general level, I think that is a game changer. And now with the strength of Azure underneath there as well, you will get more capabilities, and you are actually adding the whole cloud, public cloud value to the OpenShift platform. So basically, OpenShift 4, a smarter Kubernetes platform. You can have it up and running in a couple of minutes. You can scale because it's backed by the resources and the platform of Azure. You have one-click updates, cluster services inbuilt, a service mesh, and all other cool things that we're just not going to talk about. We're just going to show you in a little bit. And basically, it will make you help by setting it up and running it and take care of a lot of things that you normally need to take care of or need to think about, right? So what is new if we compare it with OpenShift 4.3? So basically, it's now based on Kubernetes 1.16. We have private cluster management, we have ingress endpoints, we have fully isolated cluster if needed. You can bring your own virtual network so that it's possible to connect to on-prem environments or by a VPN gateway or by Azure Express Route. Multi-availability zone clusters. So basically we deploy the different master nodes and the worker nodes across availability zones if that is possible in that Azure region. Bring your own identity provider. Obviously, we have integration with Azure Active Directory, but there's also integration with a lot of identity providers. The OpenShift service mesh, which is real cool, OpenShift serverless tech preview, and these are the things that Wian's going to talk about and show you a couple of things later on. Yeah, so let's dive in. This was just a couple of slides. I don't know if there are any questions, feel free to post them on the chat. I know Geert is doing an amazing job keeping the chat focus on that. And let's deep dive into the deployment of Azure Red Hat OpenShift running on OpenShift version 4, if that's okay. So basically, what I have created is some Azure CLI commandos, and basically I'm just going to run them through, and then eventually we're going to deploy a ARO cluster. So first things, obviously, what we need to do is we need to log in our Azure subscription, right? So let me run a commando. Let me open this real quick and copy paste the right code. Yeah, that's me. Cool. So I basically authenticated myself so that I can use the Azure CLI towards Azure, of course. And I'm going to set a couple of variables. The location, West Europe, I can change this to North Europe or East US or whatever. A resource group name, a cluster resource group name, which is what I will explain a little bit later. A pool secret. So basically, what you can do is if you want to have the certified Red Hat operators and those type of things, you need to have a pool secret. And the pool secret you can get from cloud.redhat.com. If you have an account over there, you can grab the pool secret and you can use that during your deployment so that your cluster will have access to all those amazing Red Hat certified operators. So that is why I'm pasting that in as well. And you can do it by just a text file, or you can do it just hard-coded it in. Okay, let's run this so that they know it as well. I'm already logged in. Just to be sure, I'm going to set the right subscription because I have a couple. Yeah, so that works as well. All right, let's create a resource group first. This should give me an output. Okay, and as you can see, provision status success. So now I have an empty resource group. And what I'm going to do right now is I'm going to create a virtual network, and I'm going to create two empty subnets, one for the master nodes and one for the worker nodes. So this is the commando for creating the virtual network in the resource group with the name. Let's run that. And I get an error, fine. In order to delete all resources, yeah, makes sense because I already deployed it once. So I actually need to change the resource group name. Yeah. Okay. Hold on, I can do that real quick. Let's make that 3. Let's make this 3. Well, and this is all fine. Yeah, let's run this. Don't have to do this. Creating the resource group. There's the output. And now this should work. Yes. All right. And for the masters, empty subnet. Let's go. Yeah. And for the workers as well. And what you can also do is bring your own virtual network, of course, so that you can hook it up to an hub spokes model if you have that in Azure and those type of things, right? All right, disable the private endpoint policy on the Masternode subnet so that we can access that. And that is successful. And then we come into the ACARO commandos. So basically this is the commando that you can use, and you can do a couple of things. So one of the things you can do is create and say, look, this is the resource group, this is the cluster name, this is the VNet, this is the subnet, and this is what I want to call my second resource group. And I will show you this a little bit later, how this looks in Azure. And what you can do is add the pool secret here as well, add a custom domain, change the worker node size or the work account or those type of things, right? So during the creation of the cluster, you can specify based on the needs that you need. This is basically gonna deploy a standard ARO cluster. So a standard ARO cluster consists out of 3 master nodes and 3 application nodes. And the master nodes, they're gonna be D8s. If I'm not changing that, and the work nodes is going to be D4s. So that is a virtual machine type in Azure that specifies what type of virtual machine and what are the resources that that virtual machine has, right? So let's create this. Like I said, at this point in time, I didn't provide a pool secret. So the cluster will not include samples or operators from Red Hat or from certified partners. So this is actually a good practice to do if you're going to deploy your OpenShift cluster. Get that pool secret from cloud.redhat.com, add it while you're creating the ARO cluster. So this is going to run for a little bit. That's fine. I already did it, obviously. So what I can do with AC ARO list output table is basically show my ARO clusters that I'm having, right, in Azure. I have one with a failed state. This one I just created and I canceled. The long running operation wait is canceled. And these two are succeeded. They are created. We have the URL over here. We have the name, the resource group that I determined, the location. So this is pretty cool. Now, what I can do as well, if you cluster admin rights. So if I'm saying AC ARO list credential from this name, from this yeah, it's just filled, so I need to change a different one. Let me go quick. Resource group RO RDM demo 1, for example. And the name is RO RDM. Work. And here you go, the cube admin password and the username, right? All right, deleting a cluster. Let's go back to the AC ARO list output table, because we have one in field, the one that I created and canceled, this one. So now I want to delete this one because it's in a failed state. It's not going to work anymore. I can just easily say ARO delete name RO RDM cluster 3, and then resource group ARO RDM RDM demo 3. Yeah. Obviously, we're gonna ask if you really want to delete this and do this operation. We do want that. And now it's kicking off the commando to delete this cluster from my Azure subscription. Okay, cool. So there are a couple of commandos. I also gonna add some OC tool, the top 10 of those, and I'm gonna push this to my GitHub, and I will let you guys know where you can find that. So this is basically it for creating an ARO cluster. So if you look in Azure, and how does this look? We basically have the first cluster that I created was ARO RDM demo.
Could you zoom in a bit, Roy?
Oh, sure. Yeah, hold on. This better seeable?
Yeah.
Oh, cool. So these two are one cluster, right? I created this a couple of days ago because also we had to prepare the demo and those type of things. So if I'm opening this resource group, I will see. We'll get some. In here, I see the VNet that I created, and I see my OpenShift cluster that I created, right? The location, all those type of things. And if I click on it, I see the status, the location, which version I'm running from OpenShift, if the API server is visible, what my worker VM count is. I need to zoom out just a little bit, and then it's annoying. Yeah, and also the public endpoint that I can go to log in. So why do we create this second? Do it, please. The other resource group that you saw, this one. And I didn't give it a specific name. I can do that with the ACARO create commando. I can give it a specific name. If you don't give it a specific name, it's going to be something like this: ARO dash a unique value. So if you look in this, and these are actually all the resources that we are deploying behind the scene when you do ARO create. And as you can see, public IP addresses, virtual machines, disks, all the things that we provide from the Azure platform to have a up and running OpenShift cluster, right? So that's pretty cool. Let's log into the web console. I already have the kubeadmin and the password. I think this is the right one for this. Should be, and otherwise I can just easily check. So one of the things that you're first immediately gonna notice when you deploy a ARO cluster is, out of the box right now, we don't give you a Azure AD integration. That's something you can set up yourself because we want to give you the possibility to choose your own identity provider, right? So if we go to the cluster OAuth configuration, we actually can choose from a couple of different identity providers. The basic authentication, HT password, GitHub, LDAP, like you can connect almost any identity provider. And actually, if you look at the Microsoft docs around ARO, we actually have a pretty good documentation that explains how you need to hook this up by creating a service principal and how you need to configure the OpenShift side to leverage that service principal to make it happen that you have Azure AD integration and your developers can log on using their core credentials, right? So that was one thing that I wanted to show you real quick, but also from an update perspective. So you can choose between the different channels that you want to leverage. Do you want stable, fast, or candidate, right? And right now, the current version is 4.3.13, but I have an update available, and I can just easily, with the OC tools, say commando that my cluster needs to be upgraded, I can log in into the web console and push this button and it will be upgraded. And your cluster will keep up and running, like a zero downtime upgrade. And if something fails, we are also trying to put it back, right? Right now, the way we're thinking about it is major, minor, and patch, where patching, because there's also a security aspect about that, is something that we're probably going to push automatically to the clusters. But updating a minor version, so let's say that version 4.4 comes out now, which also has been GA'd by Red Hat last week, Wian, if I'm not mistaken, right?
You are not mistaken.
Thank you. So when we have Azure Red Hat OpenShift with version 4.4, we're not gonna automatically push that, right? It's something that you as a customer, our customers need to decide for themselves when they want to do it. But it basically has a update now button, a one-click update scenario. So that's pretty cool. And also if you look at the compute to the nodes, for example. So these are the master nodes that we created, and these are the worker nodes that we have created. And they, of course, have the ready status or provisioning state or whatever status it is that they have, right? And here I can actually look at in which phase are we, which region are they in, and in which availability zone are they in. So if you look at the three masters that we are having, so master 0, master 1, and master 2. Availability zone 1, availability zone 2, and availability zone 3 in West Europe. So if something happens to my master node 2, I actually have 2 copies in another availability zone to make sure that my cluster doesn't go down. Because with Azure Red Hat OpenShift, it is a managed service. We provide an SLA of 99.9, right? So we also need to make sure that we can uphold that, and we need to make sure that your environment is stable enough and have high availability capabilities. And we also do the same thing for the worker nodes. So if you look just quickly for the machine set, and let's say, okay, this is my machine set, right? These are some of my workers, and I want to edit this, edit the count, or create an autoscaler that you can based on metrics and those type of things. And I want to deploy 3 machines in this machine set. This is all it takes. Right now, hold on. It's going to provision multiple new nodes, VMs in Azure. It's going to provision that all for you. Put it in the right availability zone, make sure that the OpenShift environment knows where they are and how that all works. All, like, you don't have to think about it. So yeah, one of the last things, sorry, yeah.
Yeah, that's also one of the things I wanted to point out. This also works in conjunction with the autoscaler option. So let's say you have a workload that's very time bound. So you have a peak every day between 9 and 5, for instance, or between 9 and 11. You can have that autoscaler create those machines in a little bit in advance so that you can deal with the peak and then have it scale down again.
Yeah.
All kinds of cool stuff like that. Yeah, sorry to interrupt, Roy.
No, more than fine. You're always welcome to interrupt me, you know that. But also from a storage perspective, if you need to have persistent volumes, if you need to have it, you can easily create Azure storage. So basically, if you look at the different provisioners, over here, you can leverage Azure Files and Azure Disks. And you can do local or zone redundant, and you can do the standard disk or the premium disk, and like all different types of storage capabilities that you can add onto the cluster for persistent volumes based on the needs that you need for your workloads, right? So all these little things combined, you don't have to think about it. Like with just a couple of buttons or commandos or a little bit of some scripting, you can easily create this and add it onto the cluster, scale the cluster out, scale the cluster in, and do all those type of things. Yeah, that's about it for me. I think it will be cool if you can show some of the innovation stuff that Red Hat is working on and works perfectly together with OpenShift, Wian.
Yes, I would love to.
Let me cancel my screen then, and then you can take over.
Yep, let me share mine.
Stop share.
Share screen. Start sharing. All right, is it sharing?
Yeah, I can see your screen, yeah.
All right, cool. So, as I already said, we created OpenShift to make Kubernetes usable for our users. Now, what does that mean? That means that we are trying to create a product that is as accessible to our basically intended audience as possible. Now, our intended audience with Red Hat OpenShift are developers, because it's great to have a Kubernetes, it's great to have containers, If developers are not using it, it's not very useful. It's only going to cost you money, and it will collect dust. So I want to go into a couple of the very cool features that we've added on top of Kubernetes that make developer life so much easier. Now, first off, I would like to talk about operators. Now, as some of you might know or might not know, we created a app store basically for Kubernetes. It's called operatorhub.io, and it basically consists of a 240, 250 ready to go operators that have been created by independent software vendors. Some of them partners of ours, some of them not even affiliated with Red Hat, so it's open to anyone. And yeah, there's a bunch of cool stuff in there. There's a whole bunch of stuff from IBM. There's a bunch of stuff out of the community. Stuff like MongoDB is in here, Cockroach, CouchDB, a whole bunch of database providers, but also monitoring software, Dynatrace, basically everything you need to have to keep your developers happy. Now, how does that work, and what does that add to your platform? Well, let me take a look at what we provide. So only 33 of these are actually ours. So the rest is all made by other companies, which we think is totally awesome. But yeah, so what does an operator do? Basically, an operator is I already said, an app store for your OpenShift cluster or even any Kubernetes cluster, and it will let you just add functionality to your platform. Now, talking about functionality, let's dive into my first demo, which is basically Service Mesh. Now, Service Mesh, I think, is a very cool development. It's been with us now for 2-3 years, somewhat. But if you are a developer and you work with microservices, a Service Mesh is basically the tool that will save your life. Now, I've installed Service Mesh on this machine by means of an operator. Let me show you the OpenShift, the Red Hat OpenShift Service Mesh operator, and this will let you create Service Mesh control planes. So you don't have to stick to one control plane. You can have multiple. If you have teams that do not work together well, or if there are security concerns, if you need to have separation, you can set up multiple. But it's basically all managed from the operator, and what the operator does in this regard is that it will monitor what needs to go where, and in this case, if it needs to be updated, it will update it. So that operator will take care of the entire management and installation of your Service Mesh. Now, Red Hat OpenShift Service Mesh is based on Istio, and it comes with some cool stuff. Now, as a good chef, I have pre-prepared a dish for you. And basically, it's the basic book info application as usually used to showcase a Service Mesh. Now, let me take you through some of the functionalities of Red Hat Service Mesh. First of all, if this is my microservices landscape, so we have a product page, we have a couple of services that take care of reviews or details or ratings. Well, it's kind of hard to see where what goes. And trust me, if you're doing this from a command line or a simple tab view, it's not getting easier. So Red Hat Service Mesh comes with Kiali. And once your microservices landscape gets a little more complex, Kiali is definitely a lifesaver. Now, dive in. I have Kiali right here. This is actually the Kiali that's running on my OpenShift cluster. And here we have a representation of that same book info application. Now, Basically, this one dashboard will show you all applications that are under control of that particular service mesh. Here I have one because it also represents the service mesh itself. But if I look at this thing will tell me, for instance, if I have configuration errors. So somebody deployed a configuration for the service mesh, and there's something in there that's just wrong. Now, Kiali will tell me that there's an error and that I need to fix this. Now, let me just go here. I'll just click the error, and here it is. It's in the details service. So let me click that, and it's basically in the version 2 subset. Now let me go to the YAML file. It will show me the configuration, and it will let me edit it. So it basically didn't find version 2 of that particular service, so it's telling me to take that out. Let me go right ahead, save, reload, and all is well. All right, so far this is not very exciting yet, right? So let me dive into the exciting bits. Now, imagine that you have a large application made out of different services. It's really hard to keep track of where everything is and what communicates with what. So we created this graph view. And basically what this graph view does is it will map out based on actual live traffic where your service mesh is. Now, because I have a very short time window here, it didn't collect any traffic. So it doesn't know where what goes. Now, let me quickly switch to my terminal because I have created a tester, which is just a basic 4-line shell script. There we go, which just calls a product page and just gives me HTTP status code. So let me see here. If I refresh this.
While we're waiting until the results come in, I have a question. So I read that the service mesh based on Istio. Is it also possible to plug in other service meshes, or does that work through the operators, or how does that work? What's the relation between OpenShift and the service mesh?
Well, basically, we provided Red Hat service mesh based on community products, in this case, Istio. So that's the product we support. Now, if you feel the need to use another service mesh with OpenShift, that is not a problem. We will still support your OpenShift. We will have your back with that. But if that service mesh breaks, we only have limited possibilities to help you out. Red Hat Service Mesh is a for free add-on to OpenShift. So if you get an ARO cluster, it doesn't come pre-installed with Red Hat Service Mesh because we think it's a user choice. People should have the choice to either use a service mesh or not. But you can add it for free. It's fully covered by the support contract. So if anything breaks, just call us. We'll fix it. But yeah, there's no limitation to whatever you want to do with an OpenShift ARO cluster. So before I was so rudely interrupted, we now have traffic in the cluster, and so Istio was able. So Red Hat Service Mesh Kiali was able to determine what goes where. Now, this is not predefined. It just knows, all right, so this comes from the ingress gateway, goes to the product page. So this is my entry point for my application, and traffic goes through it via either details or reviews, and reviews has a connection with the rating service. This is pretty cool, right? Now, one of the cool things of a service mesh is that you can do blue-green deploys and stuff like that. The version of this. which basically uses the labels that you use during deploy of your application to make sense of, all right, so version 1 of the product page is talking to details version 1. Reviews basically balances its traffic between version 1, 2, and 3, and only version 2 and 3 have a link to the ratings page. It's all organic. This is all generated. So if you deploy a additional version or an additional service or 50 additional services, this will automatically update. It will always give you an overview of what happened in your service mesh. It will also show you how many requests per second, how many were successful, your error rating, all that good stuff. Not only for the last minute, but for hours and hours if you need it. So what else? What else can you get from a service mesh? Well, we also have something I think is pretty cool, and that's distributed tracing. Now, to do that, we've included another CNCF certified project called Jaeger. And I think Jaeger, if you're writing web services, Jaeger is just awesome. Now, imagine this, right? You've created this application consisting of 4 or 5 microservices. And somewhere in that whole stream of traffic, your application is sluggish. And you don't know why, but you want to know why. Well, in that case, you need Jaeger. Now, let me do a query here. Basically limiting the results to 20. Let me see all traces. Basically, if enabled, Jaeger traces everything that goes on inside the cluster. Well, it doesn't actually do it itself. It just makes sense of the data coming out of the service mesh. Now, what can you do with Jaeger? Here I have a bunch of traces from specific hits to the application, and I can now drill down in one of these. Now let me check. I have 18 milliseconds here. I have 22 milliseconds. So there is some variation in there. It also shows that not all calls to that product page .book info run the same route. So let me find an interesting one. Let me just check this one. Now, what Jaeger does here, it will give you an exact burn down of the call in general and the actual subservices and how long it took for them to respond and how long the entire round trip of that request was. Now, that is pretty cool if you need to troubleshoot a slow running application, because you can immediately pinpoint, all right, so this call takes way too long, or this is too slow, or something goes wrong here, and this is the reason. Now, I can also do a comparison. Now, let me take this one, and let me take this one, and just do compare. Now, here I can see, all right, this is my one service, and this was the path it took. This is the other, and basically you can immediately spot, you can immediately spot differences between them. They didn't go through the service mesh in the same way. They basically hit different versions. So yeah, and on top of all that, service mesh comes with a whole host of dashboards you can use to monitor your application. Basically everything you need to monitor the health of a application. Now, this works for HTTP. It also works for gRPC and other protocols. Will be added in the future. Yeah, so this was service mesh, and now I have only one thing left to show you guys. And I think, well, this is one of the coolest parts we've added as of late to OpenShift is serverless.
Yeah, just one quick question.
Yeah, sure, go ahead.
So enabling Red Hat Service Mesh on top of the OpenShift cluster, right?
Yes.
How long did that take you to embed and have the possibilities of a service mesh inside of your container orchestration platform?
Well, it's not completely fair because I practiced a couple of times, but anywhere between 2 and 5 minutes.
Okay, thank you. Amazing.
It's a really quick and easy procedure. It's just installing an operator and presto.
Cool. Thanks.
All right.
Serverless.
So, moving on. Serverless, which of course is not really without servers. I think that name is always so false. But all right. So here I have a new project in OpenShift, and I conveniently called it Knative Serving. Now, what do we know about serverless? Serverless is all about getting that code into production fast, right? So you just want to write the code and let the system handle everything else. Now, I have this Hello World demo that I'm going to show you, and this is basically deploying a serverless function based on a pre-compiled container. Now, in here I have already. Let me just enlarge that. In here, I have the deployment for a serverless app called conveniently Hello World. And once I deploy this will get hooked into the OpenShift platform by means of Knative. Now, Knative will take care of routing and monitoring and everything around that application so that you can just focus on writing code. Let me see here. All right, OC apply. I'm using the OpenShift command line tool called OC, which is basically an upgraded version of kubectl. You can also use kubectl, whichever you prefer. We don't care. Serverless one.yaml namespace Knative serving. All right, so all is well, and let us check what we have here. And there is my service called Hello World. This gives me an overview. Basically this topology view gives you an overview of everything that's running in your project. Now, in the normal view, in the administrative view, this stuff would look like this, which is functional, but it doesn't give you a quick overview right away. I think this is more of a focused view on what your actual application looks like. You can also filter it for just your application, called Hello World. Now in here, I can just click this link and it will automatically take me to the URL generated by Knative Serving, and I will immediately get the result for my serverless function. Now, basically, I want to add, if I wanted to add another service, let's just go into doing a blue-green deploy, right? I have my old service, I want to deploy a new one, and I want to be able to gradually shift the traffic from the old to the new. Now, let me check here. I have another one here, already prepared. Well, this comes with an extra set of specs for traffic. Now, you can tag certain revisions. So the one we just deployed was called Hello World Go 1. We're deploying a new one here. So basically, we're saying here the current revision is Hello World Go 1. And we want 100% of the traffic directed to that version. Now we're deploying a new one, and we tag that with latest. And in this case, we want none of the traffic to go to that version. Now let's see what happens here if we deploy this. OC, you know what? Let's let it dangerously. kubectl apply -f serverless app2. Okay, native. All right, so everything went well. Let me check here. All right, and there's our second service. And as you can see, it also has a representation of how much traffic goes to where. So you have within this one view, immediately you know what's going on, right? So this one service is getting all the traffic, the other one is not. Now, what you can see here is a thing that's, of course, inherent to serverless. This service, because it's white, it's scaled to 0. So there's no service running. And you can see that if you hit that service, it takes a little bit. So it needs to spin up that container first and then give you the answer. So we'll get to remedying that in a little bit. Because what I wanted to show you is that you can fiddle around with that traffic now. So I can just left click here and I can just say set traffic distribution. Now in here I can say, all right, I want to have a split. Let's do 50-50 between the, that's a bit much, between the one and the other. Let's save that. And now it's splitting the traffic 50-50. So you can basically use this mechanism, and this also works from the command line. So you can also script this or whichever deployment tooling you want to use. But you can gradually shift that traffic from one function to the other or back, just so that you can make sure that any production outages during your deploy are immediately be able to remedy that, and that you have full control over which traffic goes where. All right, so I also promised you to show you how you could fix that scale to 0 issue, because scale to 0 is great if you have services that don't get hit that often and you don't want to expend the resources to keep them warm. Then yeah, of course, by all means, scale to 0. Make sure that you do know that that first call will take a little bit because the container needs to be warmed up. Now, that same application, I've created another one. It's the same Hello World demo, but I added 2 auto-scaling Knative annotations. Minus scale is 1, max scale is 10. Now I can also tell it that one container can handle a bunch of concurrent calls. I didn't in this instance because, if we're demoing this, we want a fast effect, right? So let me deploy this real quick. kubectl apply -f. Knative serving. Okay, let's check here. Of course, it added the application because I gave it a different name right here. If I go to that, and you can see that that container is just always there, and it immediately answers if you hit that link. And if you keep hitting it hard enough, it will also scale out to multiple instances. All right, that's it for my demo, guys. Any questions from you two? I think Geert is trying to tell us something.
Is it me?
Yeah, I muted myself again. So no questions for me. I was just checking the chat if there were any questions there. Thank you very much for your talk. Was awesome to see what's all in the box, because I think you get a lot of stuff in the box. I've configured my own Kubernetes clusters, and it can be quite a pain. And it sounds really promising what you showed me. So I'm curious to play with it myself as well.
Well, no, this OpenShift is not a promise. It's right there, and what we showed you today is just a small selection of what's actually in there and possible. Because we haven't even covered topics like container native virtualization and stuff like that. So there's a lot more to OpenShift than just what we showed you today.
Yeah, it sounds like a really viable solution when you want to do Kubernetes in production and don't want to spend all the time fixing the cluster yourself and focus on delivering the business value. I think that's something that Roy started with. Delivering business value is the stuff that really matters into software development, right? So it's good to be able to focus on that. Oh, I do see some questions coming in now. Can we use Azure AD for both authentication and authorization?
Yes, you can.
Yeah, I think you covered that in the beginning. So I think with that, we already took a bit longer than the 45 minutes that we planned to do this. We're going to wrap it up. Once again, thank you very much. Thank you very much, Wian and Roy, for the presentation. I really enjoyed it. Hopefully, the people in the audience enjoyed it as well. We'll be back next week with a session on quantum computing in Azure. We have Sarah Kaiser on the show, so that's another pretty cool topic, if you ask me. Really curious about what we will learn there. So join us again next week, and thank you all very much for watching, and thank you again, Wian and Roy.
No, thanks.
See you later. Bye-bye.